Hello students, welcome to the next class. In this particular session, we'll be looking on a program that is for a linear search inside the array, of course in C programming. So let's say if you have the array and array have the elements, let's say 10, 43, 50, 40, 50, 34, 67, 890, 1000, and you want to check, as a user you want to check whether a particular element is present in this array or not. Let's say I want to check as a user that element 34 is present in this array or not. So the output of the code should be yes, element 34 is present in this code. This is for part 1, and part 2 of this code is, let's say I want to check element 67 is present in this code in this array or not. So what you have to do in second part is, yes, element 67 is present, and you also have to print the index number at which 67 firstly found. Like if I say there are 267 in this array, 67 at index number 5 and 67 at index number 8. So you have to print 67 is found at index number 5. So this program is divided into two parts, and this is basically a linear search in the array. So let's make the program for that. Firstly, what you have to do is you have to include the standard input output stdio.h. Secondly, you also have to include a standard library stdlib.h. And now what you have to do is inside main function you need to have few variables of integer type, of course. Let's say int, our array name is a and size is, let's say, 10. So the array variable is a and its data type is integer. Now we have next variable I for the iteration of the loop, and now we are taking a flag variable. We are initializing this variable with 0, and now we are also taking another variable, let's say location, of integer type. Now what we have to do is, firstly we have to give the message, let's say printf enter the elements in the array. That is, this exact same message will be printed on the output screen, enter the elements in the array. Now you have to run the loop for I equals to 0. I will start at 0 index, I will go up to 10, that is I is less than 10. At every iteration I will increase by 1, that is I plus plus. Inside the loop we are scanning the elements, scanf %d, format specifier for integers, and we are storing that particular element at the address of a of I. Now reading has been done over here. This for loop completes and we have the elements inside the array. Now we are asking user printf enter the element you want to look for. Enter the element you want to look for. Now you are collecting that element using scanf. %d is a format specifier for integer, and you're storing that element. Let's say we have not declared that particular thing, so we are taking, let's say, ele, and we are declaring that in integer data type. So we have collected that particular element in our variable ele. Now you have both array as well as the element you want to look for. Now what you have to do is you have to iterate through the array one by one, starting from the 0th index going up to the maximum index, and you have to check whether that element is present in this array or not. So we'll run a loop for I equals to 0 and I is less than 10, because the maximum index is 10, maximum index is 9 and maximum size is 10, and I plus plus. Inside this, using if condition, you are comparing that element with each and every element of the array. Let's say we have the element ele and we are using comparison operator, and we are comparing that particular element with all the elements of array. So one by one it will iterate, So a of I will iterate that, and if that element is found, we are simply changing the value of flag. Initially flag has 0 value. Now if element is found, flag will change to 1. And indirectly we'll check whether our flag value has been changed or not. If flag equals to 1, that means somewhere in the array the element was present. That's why the value of flag has been changed. So the element %d is present in the array. So ELE simply. Now simply in the else part, what we have to do is we have to give the message printf the element %d is not present in the array. Using semicolon at the end. And here our first part of the code has been done, and we are closing the main function over here, and we are using Control S to save it again. So we have, from the starting part, we have the array a of size 10. We have taken the I variable for iteration in the loop. We have taken a flag variable, initialized is it with 0. We have taken the location variable, but it is of no use as of now in the first part of the code. So I'm deleting this variable over here. We'll declare it again when we are requiring it. So in the first part, the flag value has initialized with 0, and we have another variable ELE that is used to collect the particular value that user want to search. In this section, we have taken the input of array from the user, and in this section we are collecting the element that the user want to search for. And in this segment, we are checking whether that element is present or not. Flag is 0 in the starting, and we are changing the value of flag if element is found. And simply in the end, we are checking the value of flag has been changed or not. The value of flag has been changed. That means somewhere in the array the element was present. So now we have saved this file, and we are going to our file location and opening the terminal. Open in terminal. Our file name is, first we have to save as in documents. Save as in documents in C programs and save. So this file has been saved successfully. Now opening it in terminal. Simply what you have to do is, to compilation, GCC file name is linear 1.c-o, and let's say I'm giving the output file's name as linear. So I'm hitting the enter. That means file has been compiled successfully. Now to run this file, /linear linear. So file has been compiled and it is in running phase right now. So it is asking me to enter the elements in the array. So I'm entering the elements, let's say 10, 20, 25, 85, 47, 125, 48, 67, 200 and 1000. Now the array has been inputted successfully. These are the elements of the array. Now it is asking me enter the element you want to look for. So in this case, I'm looking for 48 is present in this array or not. So I have entered 48. I'm hitting enter. So the element 48 is present in the array. So the output is correct. Now again we should run this. Let's clear this and /linear. So let's say this time again 20, 52, 47, 48, 59, 78, 100, 200, 250. Now again I want to check whether 40 is present in this array or not. This time I'm looking for 40. So as you can see, the element 40 is not present in the array. So this is how first part of the code has been successfully completed. In the next part, In the next part, what we have to do is we also have to look for the element's location at which index it's present. So let's say we have to take another variable location. I'm doing editing in this code. So we have taken the variable location. At this time, simply wherever the element is found at very first time, we are collecting that location. So how you have to do that? Simply in this case, your location equals to I. That means index I. And simply you are changing over here the element percentage d is present in the array at percentage d index, and simply use the variable location. Save it and run it. Again, go back to the files, delete the previously generated output file. Now open in terminal. Now what you have to do is again compile it, gcc linear 1.c -o, and then the output name file linear, hit enter. Again /linear, enter the elements in the array. Let's say 10, 20, 58, 47, 125, 458, 124, 625, 1000, 2000. Now I want to check whether 124 present in the array or not. So simply I'm entering 124. So the element 124 is present in the array at 6 index. So it has given the correct answer. So you can count from here 0, 1, 2, 3, 4, 5, 6. So 124 is present at 6th index. This is how you make a program to search for element as linear search in the array. Again, this is just the beginning of the arrays. So I think we should stop over here for this program. In the next part, we'll look for binary search in the array. This is the linear search. Binary search is something different. So we'll look for that. Thank you very much. See you soon.